let's look at how mortgages work. Maybe you don't have a mortgage at this point, but it's basically the same as how student loans work, or rent to own, or credit cards if you don't charge anything new on them. So let's go to our spreadsheet. So it's about, for a mortgage, if it's a 6% mortgage per year, then you divide that by 12 to get the interest rate per month, so about 0.5% per month. So they charge you interest, which adds to your balance, and then you send in a payment, which subtracts from the balance. And everything happens in time steps of months. So let's create ourselves a copy here. So this is mortgage payments, balance. So now we have, for an interest rate, we have 0.5% per month. But then we also have a payment amount, and we were saying let's do, we'll copy the blue, let's do an $800 payment. Now that's actually subtracting from your balance, so let's call it a negative 800. Oh, the parentheses there is the accountant's way of writing a negative number. And our delta formula is different now. It's the interest rate times the current balance, which is basically what it was before, plus our payment each month. So I could have written a minus there, but it's nicer to keep a plus. This is, it's just nice to use pluses when you can and use a negative number to denote subtraction. So this will be time steps in months. This will be our account balance. Unlike the savings account where it was money we had in the bank, this is money that we owe. And let's say it was a mortgage of, what did it say? Let's use $100,000. And our delta formula we now have to change. It's still interest rate times account balance, but then I'm going to add on this negative payment, and I'll fill that down. But this formula doesn't have to change. It's still previous plus interest. I think what's going on here is I forgot my absolute reference with the dollar signs there. Alright, so that's looking a little more realistic. These are dollar amounts, so let's format them as dollars. So let's look at our mortgage payments here. It's decreasing, and it's decreasing faster and faster. Somewhere around month 200, we hit a zero balance, which is great. We should really stop sending them money, but apparently we didn't, so it just keeps going more and more. Most mortgages end up being, a 30-year mortgage would be 30 years times 12 months per year, which would be 360 months. So let's look at the balance at time 360. So the easy way to do that is just scroll down, find time 360. Here it is. And I want that to be 0, so I can play around with this. Right now I'm paying too much. Let's try negative 700 a month. Let's try negative 600. Let's try, oh, that's pretty close to 0. I could play with it some more, or I could do something fancy. This, under the data tab, there's something called what if analysis, goal seek, which is like a miniature version of solver. So I want to set this cell to a value of 0 by changing this cell, and it does automated guess and check until it gets that to 0, and we're good. So if I want to pay off a $100,000 mortgage, I just chose that because it's a nice round figure, not that it's necessarily accurate for any particular house. at 12%, at 6% interest per year or 0.5% per month. I need to be making payments of that each month. Some things to point out here. There is a formula that gives you this. I think in Excel it's equals PMT for the payment, but we don't need to get into that. You can look it up if you need it. You might have noticed that the equation in r squared disappeared here. Is this exponential behavior? Well, we don't usually see exponential functions that go negative or decay faster and faster. So that's kind of interesting. It's still trying to put a trend line on that, but not really succeeding. We might think that if I'm paying the same amount each month, then I would be making steady progress on decreasing the balance. But actually I make kind of slow progress at the beginning because I still owe a lot, so they still charge me a lot in interest. And it's only toward the end where I'm making faster and faster progress. So interesting, this is our first one that didn't turn out to be nicely exponential, and it's not just mildly exponential, it's way off from exponential, so we'll have to think about that.